Hello, am I audible? Sorry. Sorry. Okay. Okay. So, for today we will mostly discuss about numerical integration. So, first of all, once again, all the material here I am following the book by S.S. Sastry, which I have already uploaded in the NPTEL portal. Now here I will just discuss about numerical integration. So what is the motivation behind numerical integration? Suppose you have this integration 1 to 2 2x, just make it more easy. E की power x dx. Now if I tell you to integrate it, you can easily integrate it as e की power x 1 2, so that will be e square minus e will be the answer. Now so it is a very basic integration. Now problem with the integrations are that we are able to solve only a minuscule amount of integrations through this sort of definite approach, but mostly integrations are clumsy and complicated to solve, and solve integrations that consists of a combination of multiple functions, and combinations of multiple functions, product, division, etc. is itself a tedious task, but mostly for engineers they need solution at instance. So for example, if I ask you to consider some engineered system which is ultimately giving you this sort of integration 1 to 2 e की power tan x divided by 1 plus log x dx. So can you solve this integration? Can you solve it? So it is itself a humongous job to solve this sort of integration, right? Now what is the way out? And obviously engineers are not bothered about exact solution, and in many instances it is really impossible to construct the exact solution. So what happens? The general problem of numerical integration may be stated as follows. Given a set of data points, just like interpolation, you have a set of data points x0, y0, x1, y1 and x and yn of a function y equal to fx, where fx is not explicitly known. It is required to compute the value of the definite integral I equal to a to b y dx. Now what is our motivation? I hope that you have watched Professor Kumar's video, and what happens in this numerical technique is actually, so you have a function fx, you have a number of data points x0, y0. This x0 is nothing but a, x1, you have y1, and then you have b. At this point b is nothing, is xn, and then this is yn. Now you have exactly the function fx. You will put this x0 here, and this function will give you y0, y1 up to yn. So you can easily have this sort of relations x0, y0, x1, y1, xn, yn. Now what you will do, you will just approximate fx using Newton's forward interpolation formula. Now you can choose as many x0, x1, xn as possible. Okay, so as the number of n increases, your interpolating polynomial, Newton's forward interpolating polynomial, will be much closer to the function fx. So here the idea is very simple. What you do, if you have some complicated function such as I have given you e की power tan x divided by 1 plus log x, what you will do, you will approximate it using Newton's forward interpolation formula, interpolating polynomial. So you can have Newton's forward interpolation formula consisting 2 points, 3 points, 4 points and so on, and depending upon it, as many as xn you will introduce in the model, you will have much accuracy, but you need to pay a certain amount of cost. What is that cost? The cost is your computational labor. So for accuracy you need computational cost. So what is that mean? That if you need accuracy, is you need computational labor. So accuracy increases computational cost, and there are many higher order methods, but that doesn't mean that you will consider a higher order method of any arbitrary order such as 15 and 16. Why? Because in higher order methods, there is always a chance of round of errors, being magnified. So what happened in higher order methods? What may happen that somehow your computer or your memory, you can only handle a finite number of terms. Now if you round up those finite number of up to finite number of terms repetitively, then what may happen? The round up error may be magnified. So this means that you need to have sacrifice some amount of accuracy for the sake of minimizing round up error. So it is always advisable to consider medium range numerical things, such as the Simpson's method. Trapezoidal method is the most crude one. Then there is Simpson's 1/3 rule and Simpson's 3/8 rules. Then there are also higher order methods called Weber's rules and all. But in our syllabus there is only trapezoidal method and Simpson's method. So we will discuss these two numerical integration methods in today's class. So what happens in trapezoidal method? Trapezoidal method, your y, for example, you have only 2 points, x0 and x1. Okay, this is x0 and x1. So consequently you have a functional form y equal to fx, because your ultimate aim is to integrate x0 to x1 fx dx. So this is will give you y0 y1. So you can have this forward difference table, and then y you can approximate it as y0 plus half of y0 plus x minus x0 into delta y0. Now this is simply a linear polynomial. The degree of x is, now it is tough for you to integrate this x0 to x1 y dx where y equal to fx, but you definitely can integrate this polynomial, this simple polynomial. So if you integrate this polynomial, it will ultimately give you integration y0 plus x minus x0 up to x0 x1 delta y0 dx. Now y0 is a constant, so that will give you y0 into x1 minus x0 plus half, once again delta y0 is also constant, delta y0 x minus x0 whole square, it runs from x0 to x1. So that will give you y0, sorry, there is, I made a mistake here, it will be delta y0 by h. So y0, this x1 minus x0, consider it as h. This x1 minus x0 is nothing but your h. So this is y0 h plus half, this will give you delta 1 by h. So 2h delta y0 into h square. So that will give you y0 h plus y0 h oh, did I made some mistake? The answer is no. So that will be h by 2. And what is delta y0? This is nothing but forward difference this, and this will ultimately give you h by 2 into y0 plus y1. So this is the simplest trapezoidal rule. Now this is called local trapezoidal rule. This is called local trapezoidal rule. Now you may consider n number of points x0 up to x1 up to xn, and each sub interval x0 to x1, x0 to x0 and so on, x minus 1 to x1, within this each sub interval, what need to do? So you have you have this you have this x0 to xn fx dx. This fx is nothing but your y, so you can break it as x0 to x1 dx plus and so on xn minus 1 xn, n number of sub intervals. You apply local trapezoidal rule within for each of these sub intervals, right? Each of these sub intervals, and each of these sub intervals, just as I have discussed in the just few minutes ago, you can just write it as y0 plus y1 h by 2 y0 plus y1 plus y1 plus y2 plus h by 2 y2 plus y3 plus and so on plus h by 2 yn minus 1 plus yn. Now this will give you h by 2, this h by 2 y0 plus 2y1 plus 2y2 plus and so on 2y1 minus 1 plus yn. Here this h is nothing but you have considered n number of sub intervals, so h is called step size or length of the sub intervals, and these sub intervals are of equal lengths. Okay, so this is the called as the trapezoidal rule. Now the geometrical significance of this rule is that the curve y equal to fx is replaced by n straight lines joining the points x0 y0 and x1 y1, x1 y1 x2 x2, xn minus 1 yn minus 1 xn yn. The area bounded by the curve y equal to fx, the ordinates y x equal to x0 and x equal to xn, and the x-axis is then approximated equivalent to the sum of the areas of the n trapeziums obtained. So I will just giving you an example. So you have this curve, this is your x0 and this is your xn. So I am just considering, say this is your x2 and this is your x1. So 3 points I am considering so that you can easily understand it. So what now I will do? So this is like this. So what now I will do? I will just consider this as trapeziums, this and then join like this and then join like this. So that is how I am approximated. So you have this is your the curve and this is the area bounded by the curve. This is the total area. Okay, this is the total area, and what you are trying to do, you are fitting these trapeziums and trying to estimate that area by just calculating the area of the trapeziums. So trapeziums are constructed, that's why this methodology is called as trapezoidal rule. Okay, that's why it is called as trapezoidal rule. Now trapezoidal rule, how you will can determine? So I think sir has already discussed the error. So what happens? Dekho, in numerical you have a numerical scheme. Now if you have a need to integrate, you have a constant term, say you have a constant, you need to integrate, integration 0 to 1 into dx. So what is the original value? 1. Now you are applying trapezoidal rule. So trapezoidal rule gives h b minus a by 2, b is 1, this is a is 0, and this is a constant. So if this is your trapezoidal rule, FAB, local trapezoidal rule, so that will give you half FB plus FA is 1 plus 1, so that will giving you 1. So trapezoidal rule will give you correct for constant values also. Now for if you have this functional form, this, so what will be the value? Half. The original value is half. You need to apply trapezoidal rule, so that will give you 1 minus 0 by 2, f of a, that means f0 is 0 plus f of b is 1, so that will give you half into 1, so 1 second half. So trapezoidal rule gives you correct for 1 for x. Now will it give correct for x square dx? The answer is 1 by 3. This will be 1 minus 0 by 2, that is 0 square plus 1 square, so that will give you 1 by 2. So these and these are different, so that means trapezoidal method is actually a first order method. That means trapezoidal method will give you correct answer for functions up to linear polynomials. So if you have sin x, you are trying to integrate it with trapezoidal rule, the answer will be wrong, and there is that I am wrong, beg your pardon. So the answer there will be not free of errors. Okay, now just always remember the formula of error. I think sir has already discussed about the relevance of error. Sir has already discussed that how error is calculated. So first order method, the error is of h square, the error is minus b minus a by 12 h square y double prime x bar. This x bar is a point lying within x0 xn, x0 to xn. Next is Simpson's one-third rule. Simpson's one-third rule is again same. In Simpson's one-third rule, we will replace the function fx by the second degree interpolating polynomial. So what you need to do here, for Simpson's one-third rule, you need at least 3 points, x0, x1, because x2. That is how you can construct because if you have x0, x1, x2, you can construct y0, y1, y2. You can have just put them into the functional form of fx. You calculate delta y0, delta y1 and delta square y0. Then you consider the second order second degree Newton interpolation formula, which is just nothing but p2x y0 plus x minus x0 by h. This h is nothing but x1 minus x0 into delta y0 plus x minus x0 into x minus x1 by factorial 2 into h square factorial 2 into h square delta square y0. If you just put them, or you will integrate it, and if you integrate it, you will get the Simpson formula as you have integrate up to x0 a to b fx dx. The Simpson's 1/3 formula will be very simple. What will be it? It will be h by, it will be just this term. This will be h, means this x0 plus h increment is there, so this will be 8 by 3 y0 plus 4 y1 plus y2. Next, so if you, how you can consider the composite Simpson's rule, the composite Simpson's method, how you will consider? You will just break the interval x0 to xn into n number of the side a to b, this sub interval upon which you want to integrate. You just break it into n sub intervals x0 up to xn. The corresponding values will be y0 yn, and the composite, then you will construct these sort of things, and then what you will do, you will just add them up, and if you add them up, you will get h by 3 y0 plus 4 into y1 plus y3 plus and so on y of 2n minus 1 plus 2 y2 plus y4 plus and so on y of 2n minus 2 plus y2n. This will be the formula for, this is the formula for composite Simpson 1/3 rule. Now you can get that this composite Simpson's 1/3 rule, the error is b minus a 1 by 80 h ki power 4 y ki power, this is your formula for your the error term, minus b minus a 180 y4 x bar. Similarly, you can also construct Simpson's 3/8 rule, and Simpson's it is 1/3 rule is a good one, good method. I will not discuss Simpson 3/8 rule. I will just upload, I have already uploaded the book, you just follow it, you can easily understand and digest this. So next, these things you are not I will not discuss these things, but I request to you to go through this part, this Newton Cotes integration formula. This is a very interesting one, you just go through it. Once I will obviously upload the book, I have already uploaded the book, and you just try to learn them up. Okay, so next I will discuss a few problems. So find from the following table the area bounded by the curve and the x-axis from 7.47 to x equal to 7.52. So you have a table where you have the tabulated x values, you have the tabulated fx values. What you have to do is just to determine the okay. So what you have to do, आपको सिर्फ एक कैलकुलेशन करना है. What calculation? You have your x, so what is your age? There are total 1 2 3 4 5, so there are 6 points total. So you just need to use composite trapezoidal formula. Just use composite trapezoidal formula, so that will give you your what is your age. Age is 0.01 by 2. Then you need to just put these values 1.93 plus 2 into 1.95 plus 1.98 plus 2.01 plus 2.03 plus 2.06, and you can calculate the answer. Similarly, this is the composite next you have to apply composite Simpson's rule. So Simpson's rule is also like that. You have 0.01 by 3, so first 1.93 plus 4 into this 1.95 plus 7.51 plus 2 into 1.93 Okay, just a minute. fx0 so this will be your answer, will be 0.01 by 2. F of x0 is 1.93, and then 4 into 1.95 plus 7.50 7.50 of x1 no, there will be not this term. Plus 2 into 1 point सॉरी मैं कुछ गड़बड़ कर रहा हूँ, सॉरी. So I need to once again write it as, I will just break it, I'll clean him up. So this is your x0, this is x1, x2, this is x3, this is x4, this is x5. So this will be like h by 3 f of x0 plus 4 f of x1 plus f of x2 plus f of sorry, this will be plus f of x2 plus 4 of fx3 plus fx4 सॉरी, यहाँ पे कॉम्पोजिट सिम्पसन मेथड आप अप्लाई नहीं कर पाओगे. fx0 fx1 x2 x2 x3 x4 आप यहाँ पे कॉम्पोजिट अप्लाई नहीं कर पाओगे. composite, you cannot apply composite Simpson method here, because for composite Simpson method to be applied, for composite Simpson's method to be applied, you need 2n plus 1 points, otherwise you cannot break it. Okay, that is I have already discussed. Okay, just give me a few minutes. Just give me a few minutes. Just give me a few minutes. It is just a similar method. What you need to do, just you have the surface of revolution, you have pi y square dx, and then you proceed, just you calculate the term y square term by term and then solve them up. Okay, so this is also a very easy problem. So V is the solid of revolution. You need to determine. How you will determine? The formula is, if V is the volume of the solid formed, so the problem is a solid of revolution is formed by rotating about the x-axis, the area between the x-axis, the lines x equals to 0 and x equal to 1, and a curve through the points with the following coordinates. F of 0, it is 1.0, 0.25 it is 0.9896, 0.50 it is 0.9589, 0.75 it is 0.9089, and 1.0 is 0.8415. So correspondingly you can determine your y square. So now you can देखो यहाँ पे there are 5 points, 5 is 2 into 2 plus 1. You can apply Simpson's rule, 1/3 rule. So just the formula will be 0.25 by 3 into this 1.00 plus 4 times this and this 0.9896 plus 0.9089 plus 2 times 0.50 sorry 2 times this term, 2 times 0.9089 9589, and then lastly these two terms, this is already I have written, and then once again 0.8415. Add them up to get the final answer, and there is one pi. Do not forget to multiply this pi, so we will get the final answer to be 2.8192. This will be your final answer. Next is just application of trapezoidal and Simpson's rules. So using this trapezoidal and Simpson's rules, you can actually integrate. So this integration is quite easy, right? You can only need to integrate 1 by 1 plus x dx. The integration you can directly compute. The answer will be ln2. Now you can have trapezoidal and Simpson rule 0.5, 0.25, 0.1, 0.25. You calculate them. You calculate the x values and y values. You use the formula for trapezoidal method and formula for Simpson's method. You calculate them, and finally you can have the expression for error, and you will get to know that the absolute error, this ln, the error bound, we have know the formula. You can check, you can verify that the error of the computed value using trapezoidal rule or Simpson's rule from the original value ln2 will be lesser than the error bound which we have theoretically obtained. Okay, which we have theoretically obtained. So we have this. You will have these problems, and based upon these problems, obviously you will get one or two problems from this basic trapezoidal and Simpson rule. I will not discuss detail about these things. This is very easy. You just need to use trapezoidal. I have already uploaded the PDF. You can note down this problem. That's integration 0 to 1 by 1 plus x dx, correct to 3 decimal places, and you need to solve this example by both the trapezoidal and Simpson rules with h equal to 0.5, 0.25 and 0.125 respectively. And I hope that which you can easily calculate. Okay, so next move to our tutorial part. So I am presenting you a few problems. Okay, now we will try to solve a few problems based upon the last year's tutorials. Okay, my screen is visible. Okay, the value of integration 0 to 6 dx by 4x plus 5 using trapezoidal rule with n equal to 6 is 6.73, 4.52, 5.24, 1.22. How to solve? You have your fx as dx by 4x plus 5. Here your fx is 1 by 4x plus 5. A is equals to 0 and your b is equal to 6. You need to break it into 6 sub intervals. So that means you need to fuse 5 points in between. So 0, 1, 2, 3, 4, and 6, and you have your fx as 1 by 4x plus 5. You put the corresponding value in this fx term. You will get 0.2, 0.111, 0.077, 0.059, 0.048, 0.04, 0.034. So the trapezoidal rule is 0 to 6 dx by 4x plus 5. Your h is from 0 to 1, so that is 1. From 1 to 2 the step size is just 1. Then f0 plus twice of f1, f2, f3, f4, f5 plus f6. Now the answer will be 0.452. so answer is B. Similarly, you can also use Newton's Simpson's 1/3 rule also. How? Because you have 0, 1, 2, so that will be h by 3. You have step size 1, so h by 3, f0 plus 4f1 plus f2 plus f2 plus 4f3 plus f4 plus f4 plus 4f5 plus f6. So answer will be h1 by 3 into f0 plus 4f1 plus 4f3 plus 4f5 plus 2f2 plus 2f4 plus f6. So that will be the answer for composite Simpson's rule, using composite Simpson's rule. I am giving you 1 to 2 minutes, just you follow whatever I have and try. If you are trying to solve, just track down this, problem. Okay, so today's last problem. The value of integration 0 to 2 dx by 1 plus x square using Simpson's one-third rule with n equal to 4 is a equal to 1.105, b equal to 0.512, c equal to 2.275 and d equal to 0.398. So fx is 1 by 1 plus x square, a equal to 0, b equal to 2, n equal to 4. So that means you will break it up into 0, half, 1, 3 by 2 and 2. So what will be the values? The corresponding values will be 1, 0.8, 0.5, 0.308 and 0.2. And you know how to use Simpson's one-third rule. So first it will be f0, h by 3, so half by 3, 1 by 6, f0 plus 4 into f half plus f of 3 by 2, 2 into f of 1 plus f of 2. Then 1 plus 4 into 0.8 plus 0.308 plus 2 into 0.5 plus 0.2 is equal to 1.105. So that will be the final answer. I am giving you 2 to 3 minutes. Just summarize today's. So today we have discussed two important parts. One is the trapezoidal rule, the other one is the Simpson's one-third rule. So I hope that you will watch my YouTube videos and you will try to learn these things, and I wish you all the best for your upcoming NPTEL exam. So I will upload a few more problems based upon this. There are trapezoid. You can also search in the internet. You can search in the internet also for problems regarding trapezoidal rule and Simpson's one-third rule. Since it is a basic course on engineering mathematics, so you will mostly encounter these type of problems only. So thank you very much. Thank you for joining.